In this first question, we want to solve this equation. Cosine of 2x is equal to root 3 over 2. But we want to solve it on the interval from 0 to 2 pi. And here we mean the variable x falls within this interval. To start this problem, I'm going to simplify it a little bit. I don't want to worry about the 2x to start with, so I'm going to make a substitution. I'm going to let 2x equal theta and change the equation slightly. Instead, I'm going to solve where is cosine of theta equal to root 3 over 2. Now, there are infinitely many solutions to this equation, and to help me visualize this, I'm going to draw a unit circle. And on the unit circle, I want to indicate the angles where cosine is equal to root 3 over 2. And I know 1 in the first quadrant is pi over 6. So cosine's positive here, cosine is negative in the second and third quadrant, but then cosine's positive in the fourth quadrant again. And because of this, at this angle over here, which is negative pi over 6, cosine is also equal to root 3 over 2 for this angle. So we have two solutions to this equation. Now, they don't fall in this interval necessarily, but for theta, to start with, theta can be equal to pi over 6, and theta can be equal to negative pi over 6. But also, every multiple of 2 pi that you add to these two angles will be solutions to this equation as well. The way we express this is by putting a 2 pi n after both of these solutions. So theta equaling pi over 6 is a solution, but so is every multiple of 2n after it. And the same thing goes for this negative pi over 6. So these are all the solutions to this equation if there's no restriction on where the variable lies. What I'm going to do next is put 2x back in place of theta into these two equations. I'll put that over here. We have that 2x is equal to pi over 6 plus 2 pi n, but also 2x is equal to negative pi over 6 plus 2 pi n. Since we want to solve this equation for x, I'm going to solve this equation and this equation for x by dividing 2 to both sides. If I divide 2 here, it'll put a 2 in the denominator, making this a 12. And if I divide this by 2, it'll cancel the 2, leaving me with pi n. And the same thing happens over here. This equation becomes the following. X is equal to pi over 12 plus pi n. In the second equation, you get that x is equal to negative pi over 12 plus pi n. As a reminder, the n in these equations means an integer. N can equal 0, plus or minus 1, plus or minus 2, plus or minus 3. If there is no restriction on the interval, you would take all these values of n and it would give you infinitely many solutions. However, since we want x to be in this interval, we're only going to use a few of these n's, and we have to decide which ones that we're using. I think what I'm going to do is start with n is equal to 0. So I'll put 0 here and 0 here. If I start here and put a 0, I just get pi over 12. So here's a solution. X is equal to pi over 12. And that's good. Pi over 12 is in this interval. Excellent. So we want to include this one. This is a solution. But if I put n is equal to 0 into this equation, I get negative pi over 12. So x is negative pi over 12. But that's no good. I mean, negative pi over 12 is less than 0. So I do not want to include that. That's no good. Clearly, using negative 1, negative 2, and negative 3 are just going to give me values that are negative, which are less than 0. So I just want to use 1, 2, 3, and I'll stop once I move past 2 pi. So I guess what I mean is, next I'll use n is equal to 1. If I put 1 in place of this n, that's pi over 12 plus pi. Now, pi is 12 pi over 12. So that's 13 pi over 12 for the first solution. And that works. 13 pi over 12 is definitely less than 2 pi. In fact, if you want to get 2 pi, this number has to be a 24 pi over 12, and it's certainly less than that. So great, we have another solution, 13 pi over 12. Now, what if we put a 1 here. This is negative pi over 12 plus pi, or plus 12 pi over 12. Negative pi over 12 plus 12 pi over 12 is 11 pi over 12. That also works. So let's write that down. That is certainly greater than 0, but less than 2 pi. So far we have 3 solutions. Now let's try n is equal to 2. Okay, if I put 2 here, that's going to be pi over 12 actually plus 2 pi. That's not going to work. I mean, we don't even have to add these two fractions together, right? If you put pi over 12 plus 2 pi, I mean, that's a little bit more than 2 pi, which means you're past this number. I don't even have to simplify this. Like, we don't want to include that. But what about putting a 2 here? So that's 2 pi minus pi over 12. That seems like it'll work because it'll be a little bit less than 2 pi. Okay, so 2 pi is 24 over 12 pi, and we're taking 1 away. So that means we have x is equal to 23 over 12 pi. That is definitely less than 2 pi, and this will be our last solution. So I think I'll list them in order up here, but we have 4 solutions to this equation. X can be equal to pi over 12. Let's see, 11 pi over 12. 13 pi over 12. And the last one was 23 pi over 12. So that is a total of 4 solutions to this equation. And that is it for this problem. In question 2, we want to solve this triangle. That is, given this information, can we find side B, side C, and angle B? Let's start by solving for angle B. So this angle here. I know that the 3 angles in this triangle, A, B, and C, must add up to 180 degrees. This fact is true for any triangle. Now we know A and C, I can put that information in here, and that will allow me to solve for B. So we have that 43 degrees plus the measure of angle B, which we don't know, plus 80 degrees is equal to 180 degrees. If we simplify the left, B plus the sum of 43 and 80, which is 123, that's equal to 180 degrees. I will subtract 123 degrees from both sides of this equation, and that gives me that the measure of angle B is equal to 57 degrees. All right, so we have one piece of the triangle. I know this angle. I don't know these two sides, but we need to solve for them. I think we can find them by using the law of sines. And I think I'll start by solving for side C. Now, the law of sines says, maybe I'll write this off to the side here. So A over sine A is equal to B over sine B is equal to C over sine of C. Essentially what this law says is, if you take the measure of this angle and its opposing side, and you take this number and divide it by the side of this angle, you get a number. That number will be the same as side B divided by sine of this angle, as well as side C divided by sine of this angle. So if I'd like to solve for side C, I'm going to use this angle, and this side in this equation. It'll look like this. I'm using A over sine of A is equal to C over sine of C. The only thing that I do not know in this equation is C, which is fine. That's the thing I'd like to solve for. If I plug in all of the necessary information, I have that 6 over sine of 43 degrees is equal to C, the thing I don't know, over sine of 80 degrees. I can multiply sine of 80 degrees over here, and that leaves me with C. So that is 6 times sine of 80 degrees over sine of 43 degrees is c. And I'm just going to type this into my calculator. Now, I want to be careful. I want to make sure my calculator is in degree mode. So let's see, 6 times sine of 80 divided by sine of 43. I get 8.66. If I round to 1 decimal place, I get that c is, well, it's really approximately, but it's 8.7. Okay, great. So I know this angle. I know side C. I just don't know side B. But I think we can use the law of sines again to solve for B. I think I'll use angle A and side A, angle B, which is 57, and side B. It'll look like this. A over sine of A is equal to B over sine of B. So in this equation, the only thing I don't know is B, but I know every other part. That is 6 over sine of 43 degrees is equal to B over sine of 57 degrees. And just like the process down here, I'm going to take sine of 57, multiply it to this side, type this into my calculator, and solve for B. So B is equal to 6 times sine of 57 all over sine of 43. Okay, let's see. 6 sine of 57, sine of 43. And if I round to 1 decimal place, I get 7.4. All right, so what I know is angle B is 57 degrees, side C is 8.7 approximately, and B is 7.4. I know every side and every angle of this triangle. That means we have actually solved this triangle.